So the next step to this building generator is to get some height information and some controls to literally raise this roof, so to speak, and then add in some additional floors. Down in our geometry nodes window, I'm just going to hit the N key and click on the group tab. I'm going to select this building depth input. Now, when I hit the add button, it's going to add a duplicate of this building depth, and we're going to call this building height. We'll give it a default. We'll give it a minimum, and we'll give it a maximum value. And on the outside, I'm just going to set the building height to its default. Right now, there are no nodes that this is controlling. It's just a control that we have now at our disposal to attach to things. I'm going to hit N to collapse that again. Now, what is it that we are going to control here to begin with? Now, we're looking at the roof here, and we see that our width and height have some math connected in this combine XYZ node. But the Z is sort of fringe, so if we were to roll this Z value, we can control the height of this roof asset. Now, this Z value is going to be in meters, and so for every unit of building height, we need to multiply it by the number of meters it has to be raised. The vertical dimension for my walls or any of the building assets is 4. So we're going to have to multiply whatever value we punch into this Z value by 4. I'm going to put this control on the outside because we are going to be reusing this math to dictate the height of practically everything. So outside of this group, let's add some math. Shift A, utilities, math. And this was going to be very, very simple. Multiply by 4. And let's just get in an integer there to begin with, 1. And I'm going to connect this to the Z. Right, so now this roof has automatically been raised by 4. Now, we're not really going to be worrying too much of getting it back to 1 level because we are going to have at least one more floor here. And so this should be about the minimum that this roof asset will be sitting at. So we obviously need to connect the building height. Let's just grab this, move it in the X direction. So I'm just going to duplicate this reroute node, bring it over here, building height. Let's duplicate this again so that we can reroute this control. And let's bring this up about here so that we can plug it into this multiply node. There we go. All right, so now for every unit of building height, it's going to jump 4 meters up. It's 4. We've already got a component that is being raised, but we also have to raise this corner and these edges, and we know where they live. The corner lives in this corner frame. So let's make a little bit of room here. Just going to select all of these nodes, bring them over in the X direction to give ourselves a bit of room to add in an extra node. And we're going to move this join geometry as well. Now, because this is an object info, it doesn't have point information. It's directly instancing this roof cap corner. This is why we'll need a geometry transform node. So Shift A, going to bring in a geometry transform and plug that in here. So now that we can control the vertical location of this object information. And we'll obviously need to combine XYZ. But we know that this combine XYZ is going to change the location of these objects as well. And so, again, we're going to put this on the outside and connect it all up. So let's go Shift A, vector, combine XYZ. Now this multiply, as we know, is going to multiply the Z vector. And so we're going to connect this value for the multiply to this Z input. And then we can connect this vector to the transform. Automatically, we see that the corners have snapped to where they have to go. So I'm going to collapse this transform node over here, and I'm just going to move this over here and maybe this over here a little bit as well. Maybe we can neaten the flow of these nodes up a little as well. So now the other bits that we have to raise are these edges. And that's easy enough because we know that one point instance exists in the width frame and the other one in the depth. And because they're going to have the exact same math, this multiply and combine XYZ, as these corners, we know that we can just reroute these. But instead of using a transform geometry node, we can actually use a point transform node. Now, the advantage of this is it's a simpler node. And the reason we can is because the line mesh primitive is creating points along which this point instance then appears. Each of these objects is a point instance. This is different from the object info here, which instances just the object. There's nothing that actually distributes it. So let's get a point transform node in here. Shift A, translate. That's the one. Yeah, sorry about the confusing language here. And let's give ourselves some horizontal space as well, and we can drop this point translate right in there. Excellent. And now we know that we can reroute this combine XYZ factor to the translation input of this point translate. And now we've just got one more to do, which is the one here in the depth. So let's move some of this geometry over. And same thing, point translate down here. So we'll go Shift A, point translate, drop it in, and we know that we'll have to reroute from this to this. All right, so now we have successfully raised the roof. We'll neaten this up in a little bit. So the next element that we can add is these corner pieces. Now we've got this corner ground, which includes this corner piece, these edges, bits of footpath, and two walls. And what we want is just this corner plane to be able to fill in the area between the ground floor and the rooftop. And this is really simple because all the math here in the corners can control this. However, as we've seen previously with these walls, we will need some sort of geometry or primitive to dictate how many instances there are. Now, luckily, we've already done this. We just need a line primitive. So why don't we go ahead and make a little bit more room here in the corners area. And let's go Shift A, mesh primitive, line. Now, well, we won't attach this to anything just yet. We know that the combine XYZ and multiply should dictate the offset of this line. We have to set this to endpoints. The count will probably be coming from the height, and the end location will probably be coming from this math over here. So we can go ahead and attach this to the end location. We also know that we want this line instance to begin at about 4 meters above the ground so that it doesn't overlap with the existing corner piece. And of course, the count needs to come from the height. And now what we can do is bring in a point instance and then add that geometry to everything else. Now, what we could do is, because it's the roof, we could keep this higher. We could bring this down here, Shift A, point instance in here. Now, the object is not going to be this collection, but it's going to be from this collection. We can just go corner, plane. That's the object that we're going to instance. Now we can bring this line, connect that to the geometry, and then bring in this geometry right here. And instantly, we've got the 4 edges. We can further neaten this up a little bit if we needed to. So that's it for the corners. And that's it for all the existing geometry that we need. All we need to do now is to fill in these walls. See, everything is working just as it should. So filling in these walls is going to be slightly more tricky than filling in the ground floor. And that is because it has more in common with the roof tiles than the wall itself. It basically needs to function on a grid, but with independent width and height controls. All of the math is pretty much the same as with the roof, just rotated 90 degrees on either the X or the Y. To save ourselves a lot of time, we could effectively copy all of the roof framed nodes, and then we can replace the point instance with a new collection made up of wall assets. Just going to hit B and box select everything. And then if we go Shift D, we can duplicate this. And why don't we give this new group a name? I'm going to hit the N key, go to nodes. Instead of roof, let's call this upper floor. There we go. I'll just bring these two reroute nodes over. Instead of going in the X and the Y direction, we know that the X and Y really correspond to X and Z. So we need to flip what is going into the combine XYZ for the Y to the Z. Let's bring that Y back to 0. We'll get rid of this point instance for a second because we're going to need to create a new collection to add to this point instance. So we can flip this over to collection, untick whole collection. While we're making collections, we may as well go ahead and create that. Let's just bring these up. Maybe we make our cube invisible just for a second. We're going to need a wall and a couple of windows, and we know where to find these assets. We know that the wall plane is inside the wall, and then the windows is inside the windows P1 and P2. So I'm just going to go right click on the building assets, new collection, double click on there to relabel it and call this walls upper. And now one by one, we can select an item, and in the viewport, we can go Alt D to duplicate. Okay, I'm going to right click to let go of that transform, and then I can drag that into my walls upper. Let's go into Windows P1. We'll just need the Windows P1 and P1 plane duplicated. Alt D, and we can just drag that into walls upper. And we do the same with Windows P2. Select, Shift Select. In viewport, Alt D, right click to unselect, and then drag these down into walls upper. Now we know that the window P2 and window P1 should be in their own groups, and we can leave wall plane as it is. We'll just make a new collection in here. We'll call this window P1 U for upper, and we can put the P1s in there. Once we've got a collection inside a collection, we can shift select two objects, and in our viewport we could hit M and just go down the hierarchy to where we're allowed to put a new collection inside a collection. So I'm just going to go new collection, and we'll call this window P2 U for upper. We can make that building assets invisible again. Let's bring back our cube. We'll select this so we can take a look at our upper floor. Now we can add this collection to our point instance. So we can go walls upper. Let's just bring this down over here so we can connect that up to our geometry group output. And at first I like to test it on its own before joining it up to the rest of the geometry. So I'll just connect this point instance out to here and see if we've got anything. Well, no, because we've got no inputs yet, but we know that we need a width input. So we'll just follow the width, width. That can go into the first input, and the height input can go into the Y. Now, we've seen this problem before. We need to rotate this grid so that it faces up in the X direction. And this means that this point translate node is not going to do. We actually need a geometry transform node. Now we can select this, and if you've got your Node Wrangler enabled, you can go Shift S, and it will switch the type. So if we can go Geometry Transform, and what happens is that any nodes that are correctly attributed and have a similar kind of input will automatically reconnect. That's just a shortcut that we can do. And now we can rotate this in the X, and we know that obviously somewhere along the line, the unit spacing isn't correct. And I believe it is in the multiply for the size Y, because Y is now pointing up as we have rotated everything 90 degrees in the X. So I'm going to open up the multiply that goes into size Y, change that to 4. So while the width carries on correctly, the height is not working correctly because the math is a little bit different to this. And that's got to do with the multiply add function that goes into the combine XYZ to move the entire grid in the Z direction. This worked great for the width of 3 meters, and the multiplier is exactly half of 3. So we need to multiply this by half of 4, which is 2. We also have to add 2 so that we can get it positioned correctly. Now, when we bring the height down and up, it should spawn from the right place. Why don't we bring this wall into the rest of our geometry? I'm just going to delete those, and we're going to bring this underneath everything else. And so we will reattach this join geometry node to the output. We will reattach, this is where it gets really, really fiddly, that geometry node to the output there, and now we'll reattach the width and the height controls to where they've got to go. So we'll follow the width along here, here, and so we'll make this neat. I'm just going to duplicate that reroute node, bring that down here. Let's connect that up, and then we'll connect that to the first add. Now we'll find the height that's over here, and we will duplicate that, reroute that down, and connect that with our second add operation. I might neaten this up just a little bit further. So basically what we're looking at when we're looking at the lines is seed, height, depth, width. And so it sort of corresponds with all that line work there. All right, so now we can see what's going on. Immediately I can see that there's an extra iteration here which we need to get rid of. But what we can do, we can see that it is even. And so obviously somewhere along this line, because we've moved everything up a couple of units, we need to subtract 1 instance of wall. Now, this is fairly simple if we remember that we would add 1 to each dimension, X and now Z. And so we don't really need this add function. What I'm going to do is right-click, delete with reconnect, and now that should work correctly. So now we can duplicate this wall to fill in the back. Let's take this transform node, we'll Shift D to duplicate it and bring it out here so that whatever happens to this now can be transformed and then added back onto itself. So in order to make things a little bit less confusing, why don't we add a Shift Geometry Join Geometry node as well, so that we know that we'll be joining this geometry as well as the transformed geometry. We'll just bring that back to 0 here. That'll go in here before it gets added to the rest of the tree. So we'll just prune that, bring that one up there. So now we have 2 instances. We know that we're going to have to scale this in the y because that's what the direction it's going to face. So we'll scale the y -1. And now we will need to move this in the y direction. And as we know from previous tutorials, we need two nodes here. We need a combine XYZ. So I'm just going to duplicate this one and zero everything out. We know that it's the y that will be moving, but by how much? Let's see. 13 is the right number. We've got a building depth of 3. So we will need to multiply the number in the depth, 1, 2, 3, 4, and add 1. So let's get a multiply add in here. We've got one handy right over here. And we will have to multiply each instance, there's 4 here, by 3. And we will have to add 1. That's how we'll get to 13. And so now we'll just bring in our depth control. Let's follow the depth. We'll duplicate this reroute here. Connect that up. So fiddly. Connect that up. Bring that in to control the depth. And it looks like we've got a similar problem here, and that is that we're going to have to add 1, much like we do with the other one. So I'm just going to bring that down there. That should fix the problem. We add 1 to the depth before we bring in anything else. And so that ought to fix the problem. How come we can't add 1 to this multiply add? Well, that's because this will multiply it first and then add. What we want to do is add an instance first. So instead of depth of 3, it's a depth of 4. Then we multiply 4 by this many, and then we add 1. So now this should work perfectly fine. Excellent. So now filling in the other walls, we generally have to do exactly the same thing. So let's begin by duplicating as many of these as possible. And anything that we double up, we can just cancel out. So I'm just going to select one here. Let's box select everything. Shift D to duplicate. Let's bring that down here. So with all of these nodes here duplicated, let's connect up this transform node and let's get some of these controls also connected up. Now we are going to, the way we've done this is obviously the width is here, depth is here, and height is here. So we can follow this down, and we need to be worrying about the depth instead of the width. We need to rotate this around, and we need to connect the height, obviously, here, so that the height is correctly attributed. So now when we control the depth, that seems to be working fine. How about the height? Seems to be working fine also. So now we just need one more instance of this, which means that this will have to be moved in the X direction and set to 1 in the Y scale. So we can duplicate this transform again. Let's take this point instance and let's add this transform to our join geometry here. So that we've got all of our join geometry walls together. We will rescale that, leaving this rotation here. And now what we need is obviously a combine and a multiply node. So let's bring our combine down. Bring that into there, and we know that the X direction needs to be some factor of 3 plus 1. So we'll definitely need a multiply add in the X direction. We'll go 3 plus 1. Okay, we definitely need to connect up the width here. So the width is the furthest out. And we obviously need a plus 1 on the width. So it's very possible that this add here will have the correct setting. Yes, it does. And now with our building completed, yep, we got the height. Depth is working. Doesn't seem to be any walls flipping out around there. The width, excellent. I think we've got our building generator. Now we just need to neaten this up, and we need to connect up these random seed nodes to our control, so we can control all of the random seed from one random seed should we need it. Let's duplicate that, reroute once, because we need two of them. Reroute that as well, and we can bring these into this seed and this one into this random seed here. Because we don't have to change any of the parameters for these transforms, we could probably start to collapse these down, make them a little bit neater still. We now have controls on this building for all the parameters, as well as a random seed which will control both sets. Now, if you wanted to change the random seed to something for the upper floor and the lower floor, we will get into that in a further lesson to split things off and get a little bit more complex with this building generator. But as far as we're concerned, the basics of this building generator are now in place.